what is the exact meaning of 0 of polynomial, then I say this will be the remainder of this polynomial. Because this is a linear polynomial, the graph is touching the x-axis here, therefore we call it as 0 of the given polynomial. Hi, hello students. This is Sandhya Srihari from Vidhyapeetha 9th and 10th. I hope you are all fine, and we have come up with today's second session based on polynomials chapter. You have seen the previous session of the polynomials and I hope it's clear. We have understood everything and we can move on to the next session. This session is also an important part of the class 10 syllabus, in which we'll be making you learn in a simple, easy way so that you'll understand each and everything in a proper manner. Let us explore to the world of knowledge, as knowledge is the key power to success. So let us elevate our power in a proper way so that we can simply, easily and drastically learn maths in a better manner. Let us move on with the first topic, or going to the content. Before going to the content, just going on with the recap of whatever things done yesterday. In the yesterday's class, so in this slide, we'll be learning about the previous recap of whatever learnt in the previous video. Just having a very nice format of analyzing whatever learnt in previous session through a quick mind map. So we learnt about polynomials in the yesterday's class or previous session of the videos. So what is a polynomial? As we all know, polynomial is basically an equation in which we have three important things called as variable, a constant or a coefficient, and interlink between them is called as an operator. Can we quickly give an example of an equation? Yes, what is it? The example can be 3x square plus 2x minus 1. This is the simplest form of an equation in which we have all these three components specified. So I can say this will be my first thing to remember and the first block of the mind map. Okay. Moving on to the second block of the mind map, we also learnt about a term called as degree. What is a degree? In bracket, just noting down the main word, highest power of variable. Highest power of variable is called a degree. Now, how to just memorize the degree? I'll take a quick example. If the equation is given as x cube plus 100, x is my variable and highest power is 3. So the degree of the variable is just 3. So based on degree, we used to also have certain names of the polynomials. If my degree was 1, I used to call it as linear polynomial. If the degree was 2, we used to call it as quadratic polynomial. And if the degree is 3, we'll call it as cubic polynomial. So the three things or the three names to remember using the concept degree will be my second block in the mind map. Moving to the third block of the mind map, the polynomial was also classified based on terms. What are terms? If I use the same equation 3x square plus 2x minus 1, in this 3x square is my first term, 2x is my second term and negative 1 is my third term. So there are three terms in the given equation. So based on the terms, the classification goes like, if I only have a single term, I call it as monomial. Mono means single, so one term. If I have two terms in the given expression, I will call it as binomial, two terms. In a similar manner, if I have three terms, I call it as trinomial with three terms. Examples we have learnt it. You can just write each example in your book clarify yourself and make yourself comfortable. Sit in a proper position so that you are having a very good amount of light, as well as the acoustic of the total room is clear, so that you will be able to concentrate in the complete session, as we are doing an important part of the chapter called as the graphical representation. Many more things to learn on. Further part of the video, you'll be getting the importance of the whole session. So when we are coming up for the recap, these were the 3 important things that we learned, and we also categorized the major thing called as types of polynomials. Types of polynomials based on degree and terms, which we have learnt it in the previous video. Moving on to the next slide and starting up today's session. In this particular session, the content of the session goes for the first thing, 0 of the polynomial. Most of the students in my offline and live classes also, they are asking me, ma'am, what is the exact meaning of 0 of polynomial? It is not at all understood by us. Can you just explain it in a simpler manner? That is the reason we have come up with the basics as well as the important part of the chapter. 0 of the polynomial I'll be covering. And the next is basics of Cartesian plane. Cartesian plane, we have learnt it many times, but just a quick recap on the Cartesian plane. The third content that will be covered here will be the graphical representation of linear polynomial. First thing, I have to analyze what is a linear polynomial, and then I need to just check how to plot it across the Cartesian plane. That will give me the idea of graphical representation of linear polynomial. Okay, then moving on to the fourth, will be also representing other quadratic polynomials in graph, as well as we'll be learning some case studies based on the graph. If graph is given, how I have to analyze whether it is a quadratic polynomial or linear polynomial or various other things. Using the graph, I'll be teaching you how to understand and easily solve the question. Then we'll be just doing some more examples with NCERT question, starts from exercise 2.1 of polynomial chapter, which is covered in this complete video. So stay tuned with us until the complete video is not getting finished. Even if the video is for 1 hour, 1.5 hours, just pause the video, have some water and quickly sit down again, because the video is really going to help you out to score better in your board exams. Let us quickly move on to the next slide. In the next slide, what do we have? The first thing that is as specified in the content, it is called as the 0 of the polynomial. Let us quickly understand what do we mean by 0 of the polynomial. Any polynomial given, let us consider the polynomial that is x square minus 3x minus 4. This is the polynomial given. Now we call this polynomial as p of x. This polynomial is specified with p of x because x is my variable here. Polynomial with variable x is p of x. If I have some other variables in this specified equation, then I will call with the same variable. For example, if I have an equation with y square plus 2y plus 3, I will call this polynomial as p of y. Understanding? So whatever is my variable here, that variable is to be specified with the polynomial of x, polynomial of y, because the variable is y here. The variable is x here, so I'll call it as polynomial of y, x. So p of x is x square minus 3x minus 4. Now I have to replace x with some component, some number. For example, if I replace x with 2, so this becomes p of 2, that will be equal to 2 square minus 3 into 2 minus 4. This is 4 minus 6 minus 4. That is 4 and 4 is getting cancelled and I have minus 6 as my answer. So whenever I have replaced the value of x with any component in the position of x in the equation, x square minus 3x minus 4, and I am getting an answer here, then I say this will be the remainder of this polynomial. So in this equation, p of x equal to x square minus 3x minus 4, if I am replacing the x with 2, I am getting the answer as p of 2 is just equal to negative 6. So I can say that minus 6 is the value of x square minus 3x minus 4 at x equal to 2. So what are we basically trying to understand here? In this equation, if I replace x with 1, I can get a different answer. If I replace with 2, I can get a different answer. So the value of the variable is just changing drastically whenever we are just substituting it in one or the other equation. For example, if I take this p of x again and write it as x square minus 3x minus 4, let us consider one more value of x. Let x be equal to 2 or x be equal to 1. So this will be p of 1 equal to 1 square minus 3 into 1 minus 4. That is 1 minus 3 minus 4, which will be 1 minus 7, which is negative 6. So at x equal to 1, the value of the polynomial is changing to negative 6. When x was equal to 2, the value of the polynomial is again changing to negative 6. So there might be different answers and different positions in which we can have the same equation considered with different values of the variable and getting a different answer, which is called the zero of the polynomial p of x. So whenever an equation is given, there can be chances that in the question p of x with x equal to 2 is specified in the question, or there might be chances where the value of x is not specified. At that point of time, I have to just think for it and take a particular value of x. You have to just analyze at what point of x the equation can turn or give us an extra answer here. That will be known as the zero of the polynomial. To understand better, we have to just practice with many more questions like this, and we have just one more question taken up in the next slide. Moving on to the next slide. So I have another example here called as x square minus 3x minus 4. X square minus 3x minus 4, and we will be finding the value of this polynomial at two different positions of x, that is x is negative 1 and x is 4. Two different values we are substituting in the given equation or given polynomial p of x equal to x square minus 3x minus 4. So x is negative 1, so I'll take p of negative 1. That is negative 1 whole square minus 3 into negative 1 minus 4. Negative 1 whole square is always positive 1. Please keep it in mind. Negative into negative is plus 3 minus 4. So 1 plus 3 is 4 minus 4. The answer is turning 0. So at x equal to negative 1, the polynomial p of x is turning 0. I am repeating, at x equal to negative 1, the polynomial p of x is turning 0. Let us consider the second situation for the same polynomial. My p of x was equal to x square minus 3x minus 4. I am substituting the value of x as 4. So p of 4 is now equal to 4 square minus 3 into 4 minus 4. So 4 square is 4 4s are 16 minus 12 minus 4. Therefore 16 minus 16, again the value is turning 0. So p of 4 is also equal to 0. We can just look at the whole complete working of the question here. We are able to analyze that the same equation p of x was x square minus 3x minus 4, and we substituted the value of x as negative 1, the answer is turning 0. In the second situation, the same equation is taken and we are substituting the value of x as 4, the answer is 0 again. So we can easily analyze that when any equation is provided to us and we are able to substitute one value of that variable as at that position and the end answer is 0, then we call those two positions or those two values as the 0 of the polynomial. So, P of -1 and P of 4 in the given equation x square minus 3x plus 4 is 0. Therefore, -1 and 4 will be called as the 0 of the polynomial. I hope you all are able to understand the things. Just pause the video, look at the working at two different positions when x is -1, when x is 4. In the previous slide, just if we go to the previous slide, we are able to see that in that position the value of x substituted is not at all giving us 0 as the answer. It is giving us -6 as the answer. But in this position, when I substitute the value of x as -1 and 4, the answer is turning 0. When the answer is turning 0, then we allocate the name called as 0 of the polynomial. So most generally, we always provide P of x as P of k. If P of k is 0, then k is the value of the given polynomial. Just moving on to the next slide. So now, in order to move on to the graphical section of the chapter, before starting the graphical section, we have to understand what is a Cartesian plane. Cartesian plane is allowing us to represent two coordinate system, that is point x and point y, in a 3D format. I am considering in this position an x-axis and y-axis perpendicular to each other. Let us consider the x and y-axis perpendicular to each other in the screen. So, when we are having two axes perpendicular to each other in the screen, then we say it is a Cartesian plane. This will be my x dash O x and the vertical will be my y O y dash. Two planes perpendicular to each other at a position is called a Cartesian plane. Now, if I look at this Cartesian plane, the Cartesian plane is basically divided into 4 different parts. The first part on the right corner will always be called as the first quadrant. First quadrant. The second part will always be called the second quadrant. Third will be called as the third quadrant. And the fourth part will be called as the fourth quadrant. Whenever I look at the x and the y axis across the Cartesian plane, the point of intersection of these two axes, which is perpendicular to each other, is represented by O, called as the origin. At the origin, my coordinate system x and y will always be 0, 0. So 0, 0 is the ordinate system of the origin. Keep it in mind. When we are just looking at the x-axis, towards the right hand side of the x-axis, I always have my positive numbers, that is +1, +2, +3, +4, 5, etc. On the left hand side of my x-axis, I always have my negative number. As we all know, the same number line is carried forward here. So, x-axis is a combination of right hand side with positive numbers. This is positive. Left hand side is negative number. This side is negative. The same is applied for y-axis also. The upper part of the origin having the y-axis is made up of positive numbers, that is +1, +2, +3, +4, +5, and the lower part is made up of negative number, -1, -2, -3, -4, etc. So upper part is positive, the lower part will be negative. I have to just keep this in my mind in order to understand the sign convention of each quadrant here. The sign convention of each quadrant gives me about how to plot the various points given in the graph. For example, if my coordinate system given to me is -1 and 3, I have to basically plot this point in the Cartesian plane, for which we need to analyze what is the sign convection of each quadrant. The sign convection of the first quadrant, if I am looking, this quadrant is just having the positive of the x-axis and the positive of the y-axis. So my sign convection for this quadrant will be x and y both positive. This point represent the x and this point represent the y coordinate system. Therefore, x point is also positive and the y point is also positive. If we have x comma y specified with the coordinate system, the x is always called my abscissa and y is always called my ordinate. Together, x and y are called the coordinate points. So the coordinate points of each quadrant signifies the sign of the system as well. In my first quadrant, both the coordinates are positive, so the sign convection will be positive, positive. If I go for the second quadrant, I can check the x and y. Look at the board. This is x point, which is negative, y is positive. So the sign convection of the coordinate system in the second quadrant is negative and positive. Coming to third quadrant, we can just analyze it. X is negative, y is also negative. So the coordinate points will be both negative in the third quadrant. Coming to the fourth quadrant, x is positive, y is negative. So the sign convection will be positive and negative in the fourth quadrant. If you understand this Cartesian system in a better manner, without any doubts, you can plot the graph easily without hesitation and without mistake. So just taking an example here, let us plot certain points in the Cartesian plane specified. Negative 1 and 3 is the first point taken by me. Negative 1 and 3. So my x and y. X is negative, y is positive. So in which quadrant is this happening? It's happening in the second quadrant. X is negative, y is positive. So I'll go for negative 1 here and 3 here. The point of intersection. This point will be negative 1, 3. In a similar manner, if I have to plot 2, 2, both the coordinate system are positive here. The quadrant which is positive with x and y will be my first quadrant. Hence, 2, 2, positive 2 here, positive 2 here. The point of intersection is turning up in this position. So this coordinate system 2, 2 lies in the first quadrant. Any doubts, anything not understood by you people, you can just comment us below saying us to make a video on this. Do subscribe, like Vidhyapeetha 9th and 10th. Share the videos that we are doing so that it can be reached to the needies. Okay, moving on to the third question. If we have to plot positive 1 and negative 4. Positive and negative. Now look at the board and just analyze which quadrant is giving you positive and negative component. So positive is here and negative with y is in my fourth quadrant. So I have to go for plus 1 minus 4. Plus 1 here, negative 4 here. Point of intersection is this point. So it's plus 1, negative 4 comes in the fourth quadrant. Another point, if we take for negative 1, both negatives are lying in the third quadrant, and hence here I have to mark negative 1. This will be my negative 1 coordinate system. So this is Cartesian plane in which x and y axis are divided or perpendicularly placed to each other, and they are divided into 4 quadrants. 1, 2, 3, 4 is the quadrant name, and we can easily analyze the sign convection of it. This is the most important basic which you people have to understand so that your maths is simple, easier, and it is not going to be very tricky. It's a simple concept. If you have not understood, just comment us below. Moving on to the next content of the chapter. The next content is graphical representation of polynomials. Before this, just why did we take Cartesian plane? In order to make your basics clear, simple and easier. Let us understand what is graphical representation. Graphical representations are basically done for equations with two variables. If I am taking an equation called as y equal to 2x plus 3. There is an equation specified y is equal to 2x plus 3 and I have to plot this equation in the Cartesian plane. Whenever we have to plot an equation in the Cartesian plane, we have to just specify some of the points in the table. We'll make a table of x and y and I will generally take my own values of x and substitute it as the polynomial and find the value of y. How do we do that? Let us first consider, let x be equal to 1. If x is equal to 1, x is 1 here, so y will be equal to 2x plus 3. That is 2 into 1 plus 3, which is 2 plus 3, that is 5. I am filling up the block immediately so that no mistake is happening from our end. So when x is 1, y is turning up 5. Let us take some random value of x again. X is negative 1. So y was equal to 2x plus 3. At that point of time, 2 into negative 1 plus 3, therefore minus 2 plus 3 is giving me positive 1. Just filling up the table again, when x was negative 1, y is turning positive 1. Taking some other random values of x, let x be equal to 2. So y is equal to 2 into 2 plus 3, which is 4 plus 3, that is 7. When x was 2, y is turning 7. Another value to fill up the table, let x be equal to negative 2 or positive 3, let us take. So y is equal to 2 into 3 plus 3, that is 2 3s are 6 plus 3, which is 9. So when x was 3, y is turning 9. This is the simplest of the simplest thing what you have to understand to fill up the table so that your graphs are turning in a better manner. Therefore, after filling up the table, we are going to plot it in the Cartesian plane. This is my y-axis and this is my x-axis. Let us just start from the origin. This is 0, the origin of the both axes. Towards the left hand side, I have my positive numbers. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Towards the upper part of the origin, I have my positive numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Let us take the first point, it's plus 1 and plus 5. So 1 in my x-axis and 5 in my y-axis. This is 1, 5. Second point, negative 1 and positive 1. Negative 1 will be towards this side of the x-axis, which is here. Negative 1 and positive 1 will be this point. Negative 1, positive 1. Third point, 2, 7. 2 on the x-axis and 7 on the y-axis is turning this end 2, 7. Fourth point, 3, 9. So 3 on the x-axis and 9 on the y-axis turning here. So this is 3, 9. And when I am going to join this, when we are just joining this, I can make out this will be an exact straight line. Because this is a linear polynomial, we can see how we are going to analyze this. We can see that 2x plus 3, the variable here is x. The variable is x and the power of the variable is 1. That means this is a linear polynomial. Therefore, this equation has to give us a straight line. We have to just understand what is the equation provided to us and how are we going to manipulate the equation in the form of a graph so that our answer will be accurate. Whenever I am seeing the equation here, I have to first analyze the equation, how many degrees I can get in this and what are the various nature of the graph as well. It is a linear polynomial because we know the degree of the equation is 1 here. Therefore, this equation will touch the x-axis at exact 1 position. on the x-axis exactly at one position the equation will touch, and this graph is always a straight line. So this is the manner of representation of a simple equation taken in the form of y equal to 2x plus 3 and made you understand on how to find the solutions as well as how to plot it in the graph. This is the most important part of the chapter, where you have to understand and elaborate your own way, because the values of x are not given to you. Make sure that you are only taking certain positive values so that you will get everything in the first quadrant. If you are not able to deduce on the integers or not able to deduce on the numbers what you have to take, just message us. I'll let you know what are the important things that you have to follow. So this graph is giving us an idea on when it is a linear polynomial, what is the nature of the graph. Further, let us move on, in which we will be understanding if the degree of the equation is changing, what will be the manner of the graph that is going to be. So, going to the next slide. Hence, in this we are able to understand. Let us just quickly watch what is there in this slide. In the above equation, in this equation we had y is equal to 2x plus 3 as the equation. Y was equal to 2x plus 3. So we can find this as a linear graph. I taught you what is a linear graph, right? The linear graph is a graph in which the nature or the manner of the graph was straight line like this. This is a linear graph. This is a linear graph. When we are able to see the nature of the graph as linear, then it means that the linear polynomial ax plus b when equated to 0, I am equating this 2x plus 3 to 0, then 2x will be equal to negative 3 and x is negative 3 by 2. What is the meaning of x equal to negative 3 by 2? When I am drawing the graph and extending the graph towards the x-axis here, I can make out that the point of intersection of this graph on the x-axis is at exact position of negative 3 by 2. This position will be the point of intersection of that graph, and hence we say that this x is equal to negative b by a comma 0 will be the points of this position. Negative 3 by 2 and 0 will give me the exact value where this graph is going to touch the x-axis. Without even drawing the graph, I can easily make out by just equating this position, this 2x plus 3 to 0 and getting the value of x, so that I can make out where the graph is touching the x-axis exactly. So whenever a graph is specified or whenever an equation is specified, any linear equation, let us take one more example. If the equation was 2y minus 4, p of x was equal to 2y minus 4, I will equate this to 0. 2y is equal to 4 and y is equal to 4 by 2, that is 2. So this is a equation in which my graph will touch the x-axis exactly at positive 2. So I can make out by just analyzing the graph or equating it to 0 and understand the nature of the graph as well. That is the meaning of ax is equal to minus b and x is exactly equal to minus b by a, and hence the value of the coordinates will change to minus b by a and 0. Minus b by a is giving me the analyzation where the graph is going to touch the x-axis. Since it is on the x-axis, the system of y coordinate will be 0, exactly 0. I hope this is really clear. If not, just you can pause the video and have a quick look on the things written, make a note of it so that you are not able to miss any of the points given by me. Moving on to the next slide. In the next slide, we are able to analyze about the different form of a graphical representation. In the previous graphical representation, we have learnt about linear polynomial. In a linear polynomial, the degree of the equation was 1. Whereas in this we'll be learning about a quadratic polynomial. Previously we have learned when do we call an equation as a quadratic polynomial. Quadratic polynomials are those polynomials in which the degree of the equation is 2. When the degree of the equation, now if just we have to understand about the graph as well as relating it to the degree, when my degree of any polynomial is exactly 1, the graph of that polynomial, the graph will touch the x-axis at one position. At one position. This is the meaning of linear polynomial. Degree is 1, I call it as linear polynomial. When it is linear, the graph will touch the x-axis exactly at one position. Now if we are having a quadratic polynomial, see this is a quadratic polynomial. The general form of the quadratic polynomial is ax square plus bx plus c. I can see that the variable here is x. In ax square plus bx plus c, my variable is x and the highest power of the variable is 2. Therefore, the degree of this equation is 2. When I say the degree is 2, then looking at the graph, I am able to understand that, or without even knowing the graph, I will be saying that the graph will touch the x-axis at two different positions. At two positions. Now you tell me, if I have a cubic polynomial, where should the graph touch? It should touch in one position or two positions or three positions. Just analyze. Repeating it, if it's a linear polynomial, the graph is touching at one position. If it's a quadratic polynomial, the graph is touching at two positions. Now going for cubic, it has to touch at three different positions. Please keep it in mind. Now in a quadratic polynomial, the general form was ax square plus bx plus c. Normally a quadratic polynomial's graph will be in this manner. It will be in a ulta U or a seedha U format, which we call it as a parabola. This is called as a parabola. When it is tilted downward, we call it as a negative parabola. When it is tilted upward, we call it as a positive parabola. So if I look at this parabola and see where this graph is touching the x-axis, it is touching in this position and this position. See, exactly two positions because it is quadratic. Yes, quadratic ax square plus bx plus c, degree was 2. So when degree is 2, it has to touch at two different positions. These are the positions of intersection of this parabola on the x-axis. This is my x-axis. This is x dash over x. Therefore, it is touching at two different positions and hence I say it's a quadratic polynomial. So now, by now at least, you should be able to analyze any graph specified to us. If it is touching the x-axis at one position, what is the nature of the equation? If it is touching the x-axis at two different positions, what is the nature of the equation? That specification, if you are able to adopt, polynomials is going to be a very easy chapter for you. So, moving on to the next slide, that is giving us an information about equation which will be plotting it in the next slide. For any equation, we have or I have just taken certain values of the x. I have been specified with p of y is equal to x square minus 3x minus 4. And let us consider certain values of x here. X is 2, x is negative 1, 0, 1, 2, 3, 4, 5. What are we doing here? We are substituting certain values of x in the given equation and finding out the y coordinate system. We are substituting this value when x is negative 2. What is the exact value of y so that I can plot it on the graph is my allocation in this part of the chapter. Now let me write the equation here. Y is equal to x square minus 3x minus 4. This is the original equation. Let me write the equation here. So x is negative 2. So I will substitute that value of x here. Negative 2 whole square minus 3 into negative 2 minus 4. So this is giving me 4 minus into minus is plus 6 minus 4 plus 4 minus 4 gone. The value of y is turning as plus 6. The value of y is turning plus 6 when x was negative 2. Going to the second value, finding the second value here, x is negative 1, write down the equation again, x square minus 3x minus 4. What I have to do? I have to specify the value of x which is given, negative 1 whole square, 3 into negative 1 minus 4, negative 1 square is 1, negative into negative plus 3 minus 4. So 4 minus 4, this is turning 0. When it is turning 0, obviously the first 0 of the polynomial we have already got, correct? So x is negative 1, y is turning 0. Just after finding the value, substitute it in the table so that you are not going wrong anywhere, any part of the working. When x is 0, the third part, again writing the equation x square minus 3x minus 4, substitute the value of x as 0. 0 square, 3 into 0 minus 4. 0 minus 4 is negative 4. So when x is 0, y is turning negative 4. Moving on to the third or the fourth value, write down the equation and find the values in a similar manner. So 1 square minus 3 into 1 minus 4, 1 minus 3 minus 4, 1 minus 7, negative 6. Substitute it here, negative 6. Similar way, we are also finding the value of this. X square minus 3x minus 4 will be 2 square minus 3 into 2 minus 4, 8 minus 6 minus 4, 8 minus 10 which is negative 2. Substitute it, immediately substitute it so that you are not going wrong at all. Finding the fifth or the sixth value, x square minus 3x minus 4, 3 square minus 3 into 3 minus 4, 9 minus 9 minus 4, this is gone. So I have negative 4. When x is 4, let us check what is happening now. 4 square minus 3 into 4 minus 4, 16 minus 12 minus 4. This is giving me 16 minus 16. See here, I got the second 0 of the polynomial. Whenever any value substituted at any point of time, the answer is turning 0, I say it is a 0 of the polynomial. So y is turning 0 here. Same way, let us check for x equal to 5. X square minus 3x minus 4 is 5 square minus 3 into 5 minus 4. 25 minus 15 minus 4, 25 minus 19 is 6, plus 6. So this is turning plus 6. Okay, so these are the values. Why I have taken so many values is to make you understand whether substituted a positive number or a negative number, are we able to find out the values? Yes, we are able to find out. In your exam, you don't have to take so many values of the given equation, just 3 values of a particular equation and you are able to plot it in a graph. That's more than enough. So to make you understand, we have just taken so many values and plotted it here so that the working of each positive or negative number you are able to recognize, and then we'll be moving on to the plotting section of the Cartesian plane for the same equation. All right. So let us just try to plot the graph of the given equation, which was x square minus 3x minus 4. I have just taken the same values which was there in the previous screen in the tabulated format. Now we'll be plotting it over the graph here. First, my point x is minus 2 and y is 6. Negative 2 will lie on the left hand side of the x-axis. Here is negative 2 and positive 6 is on the upper part. So this point is my negative 2 comma 6. The point of intersection, negative 2 taken here, 6 taken here, negative 2 comma 6 is lying in this position. Second point is negative 1 comma 0. Negative 1 is here, 0 exactly on the x-axis. This point is negative 1 comma 0. Third point is 0 comma negative 4, 0 here and negative 4 here. So I will get 0 comma negative 4. Fourth point is 1 comma negative 6, 1 here and negative 6 here. So 1 comma negative 6. Then 2 and minus 2, 2 here, minus 2 here. 2 comma negative 2. Then I have 3 and negative 4. 3 here, negative 4 here. 3 comma negative 4. Then 4 and 0. 4 and 0 lies on the x-axis. This is 4 comma 0. 5 and 6. 5 here, positive 6 here. So this will be 5 comma 6, and if I have to check the nature of the graph, I can easily see that this graph is touching the x-axis at two different locations. I just omitted two of the points here, which was 1 and negative 6 and 3 and negative 4, because it was not giving me an exact parabola. So this will be the upward parabola, and since the equation was px equal to x square minus 3x minus 4, I can say that the equation has a degree with 2. Degree 2 means the equation has to touch the x-axis at two different positions. So the zero of these two polynomial here is the zeros of the polynomial will be negative 1 and positive 4. These are the two positions where the graph is touching the x-axis here. Therefore, we call it as 0 of the given polynomial. And since the degree was 2, we have to get two zeros. That we have to keep it in mind before going ahead or solving the problem in a nice manner. So, we got two positions where the x-axis, on the x-axis, the graph is intersecting. Hence, this will be called as an upward parabola. Upward parabola. So, in a quadratic equation, when do we call an equation as quadratic? When the degree is 2. If the degree is 2, obviously, it has to intersect the x-axis at two positions, and we have seen here in this example, the graph is touching the x-axis at negative 1 and positive 4. So, we will call these as the zeros of the given polynomial p of x, and since we are in class 10th right now, we will be giving the name of the zeros as alpha and beta. So alpha is negative 1, beta is positive 4. Alpha will be my first zero, which is negative 1. Beta is my second zero, which is positive 4. Therefore, any equation specified, if it is linear, we are getting a straight line. If it is a quadratic equation, we are getting a parabola format. There are different formats of parabola representation in graph as well, which we will be looking forward in the further part of the video.
In this graph, let us first try to understand what is the importance of the graph. A graph basically gives us an analyzation of how many zeros are there in the polynomial. For example, I have a graph here towards my right corner. This is the first graph. Or this is the first graph, let us consider. In this graph, we can see that the parabola is already drawn to the graph. Yes, this is the parabola. I am redrawing the parabola here. This is the parabola of the graph. How many points is the parabola touching on the x-axis? It is touching the x-axis at two different points, this and this. So can we say it is a linear polynomial or a quadratic polynomial? Can we say it's a linear polynomial or a quadratic polynomial? It is basically a quadratic polynomial because it is touching the x-axis at two positions. In my previous slide, just now we learnt about when the graph touches the x-axis at one position, it will be a linear polynomial. When it is touching the graph at two different positions, it's a quadratic polynomial. So now by just looking at the graph, we are able to analyze it. Since this parabola is tilted downwards, I will call this parabola as a negative parabola. Negative parabola, which is being framed in the first quadrant as well as the second quadrant. This is my first quadrant, this is the second quadrant. The parabola is just uplifting itself in the first quadrant and then decreasing its value in the second quadrant. So this is a negative parabola. Coming to the second example or the second diagram here, I am able to make out that this is my graph. The graph is touching the x-axis again at two different positions. Two positions the graph is touching. Again, this will also be a quadratic polynomial. So when it is a quadratic polynomial, I will say the general form of the quadratic polynomial is ax square plus bx plus c. X has a power of 2, therefore the degree of the equation is 2 and hence two positions the graph has to touch the x-axis. So determining about graph, analyzing the graph is a simple technique through which you can make your work simple, easier, as well as the concept clarity is to be known. Maths is nothing more than understanding. If you understand the topic properly, if you understand the system of representation, nothing more than that will give you the concept as well as depth. Okay. Moving on to the next slide, my dear students. In this also we are just analyzing about the graph. You can see in the third graph or the first graph provided here. Again, it's a parabola. First of all, make up a figurative representation of a parabola. What is a parabola? Parabola is a graph in which the representation of the graph is having a system of u. The representation of a graph is having a system of just in the format of u. It will be an upward u like this or a downward u like this. If it is an upward u, we call it as a positive parabola. If it is a downward u, we call it as a negative parabola. When I see the graph, I am able to recognize it is a parabola. That is one thing. Second thing what I have to analyze is the number of zeros in the graph. If I look at this graph, a very particular graph which is there in the NCERT textbook also, if we look at this graph is touching the x-axis exactly at one position here also, and here also it is touching exactly at one position. But that doesn't mean that this is a linear polynomial, correct? Because linear polynomial, as I told you, the graphical representation of linear polynomial is a straight line. Is this graph a straight line, my dear students? No, I don't think so. You also have to visualize it. Linear polynomial gives us a straight line, whereas quadratic polynomial gives us a parabola. Now, parabola is there, but many students ask me, ma'am, you're just confusing us. You told us that parabola, if it is quadratic, it has to touch the graph at two different positions as in the previous slide. But again, you are only showing a graph in which the graph is touching the x-axis at one position. This is peculiar graph in which when we have, I told you, when we have two zeros, we'll determine the zeros with alpha and beta. When alpha and beta are equal to each other, when alpha and beta are equal to each other, then I say the graph will touch the x-axis exactly at one position. Exactly at one position. Then also we will consider the nature of the graph or the type of the graph as quadratic polynomial only, and it's a parabola. So how do we recognize it? How will I get to know whether it is a quadratic polynomial or not? I will see the shape of the graph. When I see the shape of the graph, this is exactly a new format. Upward u, downward u. So a parabola is represented. When a parabola is represented, it is a quadratic polynomial. Again, after seeing it is a quadratic polynomial, I will check whether it is touching the x-axis at two position or one position. If two position, I have two different roots. That is, my alpha and beta are different with each other. If I have the parabola touching the x-axis at one position, then I will say or conclude in this aspect, that is alpha is equal to beta, implies they have equal roots. Equal roots. Please underline that word or write it in your book so that you will memorize it, you will understand it nicely. Okay. Moving on to next slide. Let us understand the next type of graph that is there.
Let us pop into the next slide and learn about case 3. What is case 3? Here we have two different graphical representations in which the first graph is again having a parabola. This parabola is just tilted in the upward manner like this. In the second graph, we again have a parabola tilted in the downward manner like this. Just redrawing it so that you are able to concentrate on the graph here. So is the graph touching the x-axis somewhere? Can you just analyze? Is it touching the x-axis? No, right? This is not at all touching the x-axis, correct? This is not at all touching the x-axis. So there is no zero for this polynomial. The number of zeros are not at all there here because the graph is not at all touching the x-axis. In the previous slide, we had a graph in this manner where it was touching the x-axis at two different positions. So we called this as alpha and this as beta. Before that, we had a graphical representation in which the graph touched the x-axis at one particular position. I told you alpha is equal to beta, but as it is a parabola, it will be a quadratic polynomial. Here also we have a parabola, but this parabola is not touching the x-axis at a particular position. Therefore, the number of zeros is again 0, or there is no zeros represented. No zeros for this particular polynomial for both the graphs. Are you able to get the things in a proper manner? If not, please pause the video and recheck what is being written. Quickly make a note of the things represented. You can also check the link below where you will be getting the notes of the particular chapter. Please do understand that every day, every time that you are watching the video, you have to learn. Learning is a process. Without learning, without memorization or understanding the basic knowledge of maths, you cannot ace in board exams. Our niche should be to make you understand mentally, physically, as well as increase your content and capability. So we are here to make your work simple, easier. In order to do that, I need your help as well. Your help, your dedication towards the watch time of the video and towards the indication that yes, or if you just give us a comment saying about the video, it will increase and make us motivated to make many more videos like this. Let us just go to the next slide and understand what is the next slide letting us to know or making us to learn. In the next slide, we have just given an importance on cubic polynomial. The cubic polynomial part of the complete chapter is basically deleted by CBSE board, but this is there for state board people. So hence taking up the topic with cubic polynomial. What is a cubic polynomial? Cubic polynomial is a polynomial which has degree equal to 3. That means if the degree of the polynomial is 3, we should have 3 zeros, 3 roots or 3 zeros should be there for this polynomial. Then only this will be called as a cubic polynomial. What do I mean by 3 zeros? That means, see, in a linear polynomial, the graph was straight line. It used to touch the x-axis at one position. If it is a quadratic polynomial, the polynomial was a parabola, U-shape. It used to touch the x-axis at two different positions. Now this is a cubic polynomial. When it is a cubic polynomial, we say it is the degree of the polynomial is 3. That means it has to touch the x-axis at 3 different positions. So quickly have a look on the graph here. This graph is having a shape of just like a N. See, the graph is having a shape of N. Like this is the shape of the graph, and if I am able to recognize the graph touching the x-axis, it is exactly touching the x-axis at 3 different locations. 1, it is touching at -2, 2, it is touching at the origin, and 3, it is touching at +2. So I can say a cubic polynomial will basically touch the x-axis at 3 different positions because the degree of the equation will be 3. In this given polynomial, y is equal to x cube minus 4x square. This is the given polynomial for which the graph is represented on the board. Y is equal to x cube minus 4x. So I have a tabulation here in which I have just substituted the value of x as -2 and worked out for y. I'll show you a simple way through which we can easily find the solution of the given equation. First, x is -2. So -2 the whole cube minus 4 into -2. So this will be -8, +8, hence my answer is 0, written here already. Negative and -8 and +8 is giving me 0, so y is represented with 0. Such type of abbreviation or substitution of the value of x is done with respect to -1, 0, 1 and 2, and we have got the y values which is tabulated in this format. When I am tabulating it, I will use the technique of Cartesian planes. I have just now taught you about the Cartesian plane in the same video. If you didn't get it, please rewind it back so that you will be able to revise it again, memorize it again. To quickly have a recap on the Cartesian plane, there are 4 quadrants. This will be my first quadrant, second quadrant, third and fourth quadrant. First quadrant, both sign will be positive. Second quadrant, one negative, one positive. Third quadrant, one negative, other also negative. Fourth quadrant will also be positive and negative. Therefore, when I represent these points on the graph here, I am able to represent, see, -2, 0 is coming up here. -1 and 3 here. 0 and 0 is coming up here. Then 2 and 0 is coming up here. So when we are able to check and plot all these points together, I am able to see that this is a polynomial which is touching the x-axis at 3 different locations. Therefore, I call this as a cubic polynomial. So when we have to just glance the chapter, even if you are not watching any YouTube channel or you are not in front of any of your teacher, mentor, your textbook is going to give you the total complete visualization of the content. In the textbook, you can see this graph. It is represented in the form of an example in cubic polynomial topic. So this explanation is basically important for us to understand the content, understand the chapter in a better manner. View the graph in a proper way, plotting of the graph in a proper alignment with positive and negative values, as well as understanding what is a zero, how many zeros we are going to get when the degree is 1, 2 and 3. That is the most important thing of the chapter. So let us go to the example section of polynomials. This is an example taken from example 1 in NCERT textbook. Okay. In this example, we are going to analyze how many zeros are there for this polynomial. Okay. So look at the graphs in figure 2.9 given below. Each of the graph of y is equal to p of x, where p of x is a polynomial. For each of this graph, I have to identify the number of zeros. So what I have to find from the question, that is the most important thing, because I need to understand what should be done. Correct? If I don't understand what I have to do it in my answer key, then I will not be able to get good marks. That is the reason whenever you read a question and the question is giving you a phrase here, underline the phrase in a pencil so that you are not missing those points here. Now coming to the first graph here, you people tell me how many zeros are there for this graph. Let us see where is the graph touching the x-axis at this point. Only one location. So the number of zeros for this will be 1. Correct? Let us fill the answer column. Number of zeros, 1 for the first graph. Second graph, 2 different locations. The graph is touching the x-axis. So number of zeros for the second graph will be 2. It's a parabola, downward parabola or a negative parabola. Correct? Going to the third graph, it is touching the x-axis at 3 positions. See, I'm marking the positions also. Do it with me or else pause the video and have a check again. So 3 different positions, the graph is touching the x-axis. Therefore, number of zeros for the third graph is 3. Now you people just analyze what is the number of zeros for the 4th, 5th and 6th graph. For the 4th graph, it is touching, see, it is touching the x-axis exactly in one position. we will not take this position where it is touching the y-axis. This is not required for us. We should only mark this because I am only counting the zeros with respect to the x-axis. Therefore, fourth graph is giving me the 0 as 1. Fifth graph, it's a parabola and touching the x-axis at one position, so alpha will be equal to beta, but number of zeros will write it as 2. Third graph or the sixth graph here, 1, 2, 3, 4 different positions, so number of zeros 4. By this time, you should be easily able to understand whether a graph is given, is it a linear polynomial, a quadratic polynomial or a cubic polynomial, or more than that by just looking at the number of points on the x-axis. As the first graph says, it's a linear polynomial. Second graph, it's a quadratic polynomial. Third, cubic. Fourth, linear. Fifth, quadratic. Sixth is a polynomial with degree 4. Therefore, this is a simple example taken from NCERT textbook, which is giving us better idea and the nature of the graphs in different format. Let us just go to the next part of the slide. Now we are starting with exercise 2.1. okay, we have completed the content of the syllabus in which you have learnt about various degrees, various types of representation, finding solution of the graph, and we have just reached the exercise part of the chapter, starting with exercise 2.1. In exercise 2.1, as the example was done in the previous slide, the same type of example is given in the format of the exercise. Here I have the polynomial y is equal to p of x is given below, and we have to find, I am underlining what I have to do here. Therefore, just taking up the pen and underlining, I have to find the number of zeros for p, the polynomial p of x. First graph, you people tell me now, come on, first one, is it touching the x-axis? No, it is not at all touching. Not touching the x-axis. X-axis. Therefore, the answer for the first one, no zeros. Will not write 0 zeros. Will write no zeros. Okay, no zeros. Second question, it is touching at one particular position. So I can say second question will be degree 1. So number of zeros will be 1 here. It's a linear polynomial. Third question, the number of positions that the graph is passed to the x-axis is 1, 2 and 3. Therefore, 3 zeros. 3 zeros means cubic polynomial, right? Cubic polynomial. Are you able to understand? Are you able to analyze it? If not, quickly comment us so that I will be able to make further more videos on the same topic and make you or clear your topics in the relevant aspect. Okay. So moving on to the fourth one, two different positions, 1 and 2. So for the fourth one, we have 2 zeros. 2 zeros and it will be a quadratic polynomial. Fifth one, 1, 2, 3, 4. Therefore, fifth one is 4 zeros. 4 zeros. Sixth one, 1, 2, 3. So it is cubic polynomial. 3 zeros. 3 zeros, cubic polynomial. So see the beauty of maths. I can basically change the values of x and y and create so many patterns in a very nice way and represent it in Cartesian plane. So look at the beauty of maths. If you understand the depth of the concept, obviously you can frame any equation of this sort on your own as well. If you are unable to do any of the question, you can just comment the same question or type the same question in the comment section so that we will be able to find the solution for it and upload it as well. Alright, so this was based on the exercise 2.1. Thank you for watching. Like us, subscribe us. This is Sandhya Srihari from Vidhyapeetha and see you in the next video. Do share our videos to the friends and your known community so that it can reach the needy as well as it will be helpful to all of you. Thank you so much for watching.